Assalamualaikum and welcome to our presentation. Today we are going to talk about a useful method in chemistry called gravimetric analysis and how we use it to detect sulfate in wastewater. Let's begin by understanding gravimetric analysis is and why it matters. Before we start, let me introduce myself. My name is UMAIDAH binti Zuraimie with student ID 2022-859626 and this is my team members. Wan Anis NASUHA, SITI KHADIJAH, Nur IZZATI and SAHIRA. So, what is gravimetric analysis? Gravimetric analysis is a method in chemistry where we measure the mass of a substance to find out how much of a certain chemical is in a sample. It usually involves making that chemical turn into a solid, then drying and weighing it. This method is very important because it gives very accurate result. It's often used in labs and industry to check the quality of product, control pollution, and make sure processes are safe and efficient. In this presentation, we will focus on how gravimetric analysis can be used to find sulfate ions in wastewater. Sulfate can come from factories or detergents, and too much of it can harm the environment. Using gravimetric analysis, we can measure how much sulfate is present, which helps in keeping water clean and safe. We also talk about procedures step by step and give an example data interpretation.
So now I will be explaining the theory behind gravimetric analysis, which is the method used in this experiment. In theory, gravimetric analysis is a technique used in chemistry to find out how much of a certain substance is in a sample. It works by changing that substance into a solid form, which we can then filter, dry and weigh. So why gravimetric analysis is used for sulfate? Because it gives the accurate and reliable result and also good for measuring sulfate in wastewater. So, in our case, we want to determine how much sulfate ion is in industrial wastewater. To do that, we add a chemical called barium chloride to the water sample. The barium ions Ba2+ will react the sulfate ions SO4 2- in the solution. This reaction forms a white solid called barium sulfate BaSO4, which is insoluble in water, meaning it doesn't dissolve. So this is the chemical equation for the reaction. The reactants are SO4 2- and Ba2+. These are the ions dissolved in water. The product is BaSO4, a solid that forms as a white precipitate. So this solid barium sulfate is what we collect by filtering. After that, we dry it completely and then weigh it. By using its mass, we can calculate the amount of the sulfate that was in the wastewater. So, in a simple word, gravimetric analysis helps us turn something we can't see, like sulfate ions, into something we can collect and measure. And that's how we determine the sulfate content in wastewater using this method.
Gravimetric determination of sulfate in wastewater began with proper sample collection. In this study, samples were collected from 5 industrial facilities in Nigeria, which is Nesco Company in Jos Plateau State, Dana Steel in Katsina State, KRBC in Kaduna State, Niles in Zaria, Kaduna State, and KCV also in Katsina State. At each site, effluent was taken from industry's discharge outlet using clean plastic bottles. These bottles were rinsed with distilled water to remove contamination. After filling, samples were labeled and stored properly for analysis. To begin the procedure, each sample was stirred thoroughly. Then 20 milliliters of sample was measured into 250 milliliters beakers. Then 150 milliliters of distilled water was added, followed by 2 drops of hydrochloric acid. The solution was then brought to a boil. 30 milliliters of 5% barium chloride solution was added slowly while stirred gently. Then, 5 milliliters of silver nitrate was added to help the barium sulfate precipitate form and settle. The mixture was placed in a water bed for 1 hour. After the solution was left to stand, the clear liquid was poured off. The solid precipitate was filtered using pre-weighed filter papers. Then dry in an oven overnight, cool in a dessicators and weighed again. To calculate the sulfate ion present in barium sulfate, the gravimetric factor is used. The molar mass of sulfate is 96 gram per mole and the molar mass of barium sulfate is 233 gram per mole. When 96 is divided by 233, the result is 0.4125. This means every gram of barium sulfate contains approximately 0.4125 gram of sulfate.
Next is data interpretation part. From this article, we got some data, some table and chart that we have to interpret. But first, let's go through the first result, density. As shown in the table, nylon industry has the highest density of all the industry because the higher concentration that it has in the effluent, such as organic compound, salt, heavy metals, or other industry chemicals that lead to the high density. And KCV is has the lowest density, 0.95 gram per mil. The second data interpretation is about total suspended solid, or TTS. To get better understanding, what is TTS? TTS is what we can see floating. So for example, if we stir a spoon of sand in the water, the particle that float or settle later, we call it as TTS. Based on the result, all of the effluent of the industry exceeded the WHO and FME standard for TTS except KRPC industry, where these four that exceeded the standard would have lower clarity of water. The water appear more cloudy and more murky. So the third interpretation and the third result of the article that we got is total solid, or TS interpretation. So what is TS? TS is everything in the water, including the TTS that we just talked just now. So TS includes both floating TS and the dissolved stuff that we cannot see, such as mineral, chemicals, and salt. So for example, if we boil the water until it evaporates, the residue that left, we call it as total solid. So for the table, only NASCO industry and nylon industry exceeded the FME discharge standard, and this indicates that high pollution loads potentially harmful to aquatic life and unsuitable for discharge without treatment, where the other three is environmentally accepted. So what is the impact of high TS? High TS can reduce light penetration in water, lead to the affect aquatic plant photosynthesis, and it also increases water temperature and clog fish gills and smaller habitats.
So the last one for data interpretation is percentage of sulfate from sample. As we can see, the percentage of sulfate obtained from each sample were 40.65%, 7.35%, 6.19%, 17.93%, and 29.01% for NASCO, Dana, KRPC, Nylus, and KCB respectively. A new technological treatment process is recommended for these industries to provide good ways on waste management that are economically viable. On this table, we can see that KRPC shows the lowest sulfate level, which may reflect better environmental practice or less sulfate usage. Meanwhile, KCB stands out with the highest sulfate concentration, suggesting a need for improved effluent treatment or sulfate recovery.
So the conclusion is gravimetric method is one of the simplest, fast, and low-cost way to determine sulfate in industrial effluent. Results show high sulfate levels, highlighting the need for proper treatment and recovery systems. Hence, new eco-friendly technologies are recommended to reduce pollution and follow environmental standards.
In conclusion, gravimetric analysis is a useful and reliable method in chemistry. It helps us measure how much of a substance is in a sample by making it a solid and weighing it. In our project, we use this method to detect sulfate in wastewater. Too much sulfate can harm health and the environment. Gravimetric analysis helps us check if the water is safe. This method is simple, low cost, and gives accurate result. It's very helpful in labs, industry, and for protecting our water and environment. And that's the end of our presentation. Thank you for watching. Bye bye.